As usual, waiting for Twitch to catch up. Any second now. There we go. I should be live. Hello, everyone. Welcome back to the stream. This evening, I'm gonna keep it short because I'm very tired, but we're just continuing what we've been working on all week, which is finishing the refactor of the analysis phase. We've made a lot of progress this week, and yeah, let's just jump back into it. Okay, this is where we left off yesterday, starting to do the function instantiation at the end of the analysis phase. So let's go back to this. One thing I wanted to change was the name of this function. Step is very unclear. Process batch is a lot better. This process a batch of instantiations, and before doing so, clears the buffer that stores all of the functions that need to be instantiated, and at the end, fetches the buffer to see if any new functions need to be instantiated. This iterate until m will repeat process batch until this function returns an empty set of requests, basically. Another thing I want to change is I think I want instantiate to just do the job of the instantiation, but not care about matters of caching or anything like this. As a result, I think all of the decision about whether something should be instantiated, should be read from the cache, should be done as part of this thing and not as part of this function. So let's do that. So here I'll introduce instead a new function, which is going to be process request, I suppose. And here process request is going to probably look at the content of this to be able to decide, do we need to do this one or not? I'm going to copy some of this. I might even... Now, will I need the name as part of this, or will I not need it? I might not need it. Okay, so this will be... Let's look at the symbols in the cache. Which means, have we already processed this exact function? So we need to decide how to make the name, but we can do that in a second time. And I suppose this function doesn't care about returning a value, which means I can do, instead of doing this, I can do an unless m even, I think I want. Let me go back to Google. Unless m, I believe, is the one I want. It is in control mode extra, perfect. Given a monadic action that gives me a boolean, perfect. So unless we find it in the map of processed symbols, then we want to do something. What we will want to do is get the symbol, which will be either we find it in the other symbol cache, the one that comes from other modules, or we process it locally. What does that mean? Because in theory, you might be asking, like, a symbol is local to a module, therefore why would I look for a cached version of it in another module in a dependency? And the reason for that is generic functions, because generic functions are going to be included in the symbols of the module that instantiates them, kind of like how C++ functions will be, when instantiated, compiled within their own compilation unit. So what this says is, if I have a module A that introduces a generic function foo, but does not instantiate it, A will not contain a instantiated version of that function. But if a module B that depends on A instantiates foo for like foo of int, for instance, then B will contain the symbol for foo of int. And if C depends on B and also instantiates foo as foo of int, it will need to contain the symbol for foo of int because it needs to be able to link against, because it depends on it. But if B has already compiled it, might as well reuse it. Hence, looking in the symbol cache from dependencies to be able to decide whether, like, to try to see if we can skip having to recompile a function that has already been compiled as part of this process. So we do a very similar thing, which is this thing here, but rather than being a use that looks into the state here, we do a views that looks into the reader state here, and we are looking at VI symbols. And here we don't just do a member, we are not checking a Boolean information of whether the information is in the cache. We're doing a lookup to actually get the value. And on nothing, so if we don't get the result, this is where, no, actually, okay, we did not get the value, we need to do something. And the thing we need to do is instantiate using the request, which will give us here, that's gonna be a validated function info, which is what a symbol is, basically. I can remove the do here, and when we have the symbol, we can add it into our cache, the one here that we were checking, which is done by doing this. We modify the shared state, the current state, by inserting into this, the thing pointed by this lens, so this symbol's thing, this symbol cache, we insert at the given name, the given symbol. Okay, so that should be all for this function here. I might just introduce a new line just for readability. There we go. The only thing we're missing is how to make a name from this. So we have in the function instantiation request. Oh, we don't even have the base name. Shouldn't we have the base name? Oh, I think the function info contains the base name. Oops, not what I meant to do. I meant to do this. And go back to... This is a resolved function info. And a validated function type. Wait, let's look at resolved. Function info. It's the common one. It's just a fun name. Okay, so we are definitely missing something. Because here I have the code of the function that needs to be analyzed. Oh, unless the function type invalidated that we have here as well contains... Nope. Okay, so we are missing something here. We are missing the base name of this function we are trying to instantiate. Okay, so before we go any further, we might want to fix some of the validation to make sure that we include... This would be here, invalidate function type. I think this is going to be slightly incorrect. We're going to have to change this. But for now, here I am missing the base name. And that's going to be... How do I get the base name here, actually? Oh, I have it in the scope, right? I think. I have it in the context. If I look at the current... Yeah, I'll have the current name as the base name. Okay, so I can do that. I can get... The base name is current... Is at current name, I believe. And that's the base name. There we go. With that in mind, here, we can create a name, and the name is what? It is a base name plus type information. So here we have the base name, which comes from this base name we've just added to the thing. And we have... I might not need to give all of this, actually. So maybe instantiate will take a subset of this request. The requests, I need all of that information to be able to process it, but I might not need all of it to instantiate. I will need to know... To make the name, I need to translate this list of concrete type into a name. I think I have an expect name function in expect. In expect, indeed. I don't? I thought I had. Huh, maybe it's just part of the expression then? It's not. Fascinating. I was convinced I had an expect... Oh no, I removed it because I changed the way names are processed. Okay, so we might just redo it. We might just redo it. I go back here. So what I will want to do here is simply a map expect a name on the type parameters. That will give me the list of names that correspond to the types that are given as an argument. And that will give me the unique symbol name of the thing we need to instantiate. And that should be all we need. And I think here, yeah, I'm going to have to change something here as well. Okay, so I need expect name. I should have invalidated a toName function. There we go. There it is. Or get type name. I suppose just type name is cleaner. It may return nothing just because some things will have a type which is function, and that doesn't have a that doesn't have a type name, because function types are not persisted in any way. However, expect name will be something that, given a type, gives me a name. And the idea of... Oh, I know I changed my naming convention, haven't I? I've used assert for things that will fail with an internal compiler error if something is wrong. So I should actually just check to be... Yeah, okay. So I will want to assert name instead, to be consistent with other function names. And assert name is just going to be type name into, well, given some type, and on nothing. Or I guess I can just write it 0.3 as being type name, and from maybe... actually, no, I will want the type just because I need it for the internal compiler error message. So this is going to be get the type name, and on nothing. Oops. I'm just going to do that here so that the indentation is better. This is going to be reporting an internal compiler error. I need to get rid of this first argument. It's not... It's bad. I'll do that because it's usually not very descriptive. I would rather have this thing take the name of the function. Since they're going to be a stack trace anyway, the name of the function that does this assert will appear and will provide the context. So this first argument is useless. I'm just going to remove it. Name not found for given type. And we will include some details. The type is going to be simply show of t. There we go. Okay, so back to our instantiation. This is no longer expect name, this is assert name. Okay. I mean, ideally at some point, I'll support having function type syntax in the language, therefore things can be parameterized by function types, therefore that function that gives me the name of a type is total, and then suddenly things are a lot better. So I wanted to check something else, which is when we do the validation, we do some context manipulation before calling the validation function. Namely, we do, so the definition stack is no longer a problem because when we instantiate functions, we've already done, like we validate them basically, we've already done the rest of the work. There is nothing, like every type, every declaration has been processed. So it's purely a matter of instantiating the functions now. So this definition stack is no longer required. That's not something I care about. I think the context I do care about. What function am I in? What is the current location? What is the function type that I need to check for return values? And what are the type parameters in scope? So I'm gonna need, I have this with context function, which I think only initializes, oh, name is incorrect. That's a base name. There we go. Name and location, puts a context at the beginning. Perfect. So I think we will want to copy this. We will want to copy this with context and bring it here. Being in on nothing M makes this a tiny bit less readable, but that's fine. Yeah, that's fine. I can even do that so that the arguments are very clear. There we go. I might not need all of the instantiation request because the base name is already now in the context. I can access it whenever I want. What I probably need, if I need 3 out of 4, I might as well just give the full context. Okay, so what do we do here? We're gonna need to start by processing the function type and adding adding the type parameters in the scope as a form of a hash map from identifier to concrete type. So let's already decompose a few things. I have the function info here, which is coming from common. So let's do a I might actually expect resolved to export it, so I'm going to do that instead. But it's on the constructor, so no, I will need to be very clear about what constructor I'm unpacking. And that is the one that is coming from the request definition. So now I have all of those things, which is the fun type and the fun body in scope, which is what I want. What else do I want to unpack from this? The function type, the validated one. There is a tiny bit of overlap there between the two of them. Yeah, so I probably don't need to unlock all of this. The body is all I want because the function type, I already have this resolved version, which is a lot better. So I can scrap that altogether. Instead, I think I will want to unpack the validated function type. That gives me a lot of information, which is coming from, yeah, there we go, the fun type. What I will want to do first is create the association map. Here, I suspect that since I have performed a check, yes, since a function is instantiated, if I have checked its type somewhere, either by validating the top level declaration or because I have encountered a function call to it, I know that the number of type arguments is correct in the scope, so I don't need to check it. So I don't need to check that the number of arguments given to me in the request, which comes from this, matches the number of things here from the identifier. So here I'll actually need the base name. Well, it's in the scope. I can just get it base name from current name. Then I will need, actually I'm gonna do it in this order, because I can then create the parameter mapping, which is going to be a map from list of zipping the fun parameters that are coming from here, which is just a list of the identifiers, with something that puts the base name at the beginning of... Oh, I'm an idiot. That's the other way around. The key is base name and the parameter name. So this is my key, a tuple base name identifier name for all of the identifier names. And my values is the concrete type that is coming from the request. So this. In fact, I don't need to introduce it as a thing. Here, I can directly set in my context. So current params is set to this. Then, I think the last thing we need to do here is we need to set the return value. Aha, so this needs to be a maybe here, because I want to distinguish... The reason why I had removed the maybe here is if there is no type given for the return type of a function, then it is unit, basically. And when I validate a return statement, I need to check, but I guess I can, instead of checking if it isn't there, it must be unit, I can just check, is it, if it's not there, like, yeah, okay, I think I can just do that. Which means... but that's a bit annoying then. Although I suppose I can just always put a concrete type there. I'm almost tempted to make instantiation a separate monad, since a lot of the context is only useful in the case of a function. It's easier to keep it that way, I think. So I'm just gonna change with context to be by default, since this is a concrete type, I believe. Yeah, by default this is a concrete type. By default this will just be unit type. There we go. And the very first thing I'll do here anyway will be to set that the current fun type is the return type that I got from this thing. Okay, do this and this. Okay, so now my context is initialized. I know what my types match to in the current context. I already have done the function type. The resolution of argument names and all that is already done. Let me think about something for a second, though. In the resolved version of a function, if I have something that points to a hello, how are you? If I have something that points to an argument, it will have the role argument. So if I look at resolved and I look at a role, it will have the type function argument. Okay, and it will contain the resolved arg type. So I will have the type there. Doing okay. The shot was a bit tiresome, so I'm probably not gonna like stream for like 6 hours this evening or anything like this. But I'm doing okay. Okay, so I will have type information. So I think since the type has already been validated, and at this point I'm only caring about the symbol, I think I can ignore all function arguments in this context. And at this point, the only thing I need to do is where's the function info in there? I just need to create this thing that will contain the type that I already have, because that's a function type here which I already have from my request. Here, that's the one. And I just need to create the body by iterating over the body of the function and doing the validation. So this is going to be, I'll get the block by doing a validate block. Oh, I'm missing something. So validate block is what I'm going to need, which I will get from fun block, fun body. This is going to be ambiguous. I'm going to have to specify which one, which is coming from the definition. Okay. And that I think is enough to get started on the process of validating the code of a function. When I get the block, then the only thing I have left to do is to create a validated function info, and that only contains the fun type, unchange, and the function body, I suppose. Now, there's one thing I should be doing. I think I want to try to instantiate functions, like to collect as many errors as possible. So I should be doing I think I'm tempted to do a thing that's slightly inelegant, but I think is better, which is to basically silently catch any error that happens while processing a function. The only thing is, if I do that, then a recursive function might. Yeah, okay, I can't do that. I need to be more subtle than this. The problem being that if that I need to keep a separate cache. My idea was I'd always silently ignore errors when I try to instantiate a function. It will still be an error at the end, but so that I can try to instantiate as many of them as I can. However, if I silently do this, then I don't have a symbol at the end to insert into the thing, which I use as a cache to determine whether I should process the thing. So if a function calls itself recursively and then errors, it will not give me a symbol because it has failed. I'll swallow the error silently, and I'll have registered itself for instantiation, which will break. So which will loop indefinitely. So I need something a bit smarter than this. And I suppose rather than looking at the symbol cache. Actually, do I use the symbol cache for anything? I think I don't, since now I never instantiate functions as I encounter them, as I encounter the definitions. I always do a batch of instantiations when all the types have been processed. I might no longer need. I might no longer need the symbol cache at all. In fact, I'm fairly certain that if I look for the VS symbols thing, it is defined here and only used in this file. Okay, so I probably just don't need it. Which means, where's my run function? I don't have a run validation function. Oh, I'll need to fix that. Okay, well, that makes it easy. I don't have to fix something that isn't implemented yet. So we'll fix it when we actually write it. Now that means that since I am not populating a cache, I need to return the result, which is going to be this symbol cache. And this is going to be instead this. So I'm going to use, this is basically like a loop where this first tuple is the initial condition, which is what functions I need to instantiate what is my cache, basically. And this function, as long as this thing is not true, this function will be called, which will yield the new accumulator, basically. And this new accumulator will be what new requests have popped up since last time, and what is the current state of my cache. When it finishes, when there's no longer any request to proceed, I'll have my symbol cache. But here I'm going to do something a bit more subtle. This will be f-mapped into it because this is in the monadic context. And I'm going to change something. I'm going to... Oh, do I have that in my prelude? I don't. Is that a functions in map strict? There we go. There it is. Is there a... There is a map maybe, but there isn't a cat maybes. There isn't a cat maybes. That's very annoying. That being said, that's just an ID, I suppose. Yeah, that's just map maybe ID. I'm surprised. I thought I had done something like this. Oh well. Oh wait, no, I might have it. There we go. Cat maybes. There we go. I knew I had it somewhere. So in data hash map strict extra. Qualified as M. Qualified as M, even better. Wait, I already had it. Okay, so that's... okay, ignore me then. So here, then I can do is... So I get the second thing of my accumulator, which is the actual cache which contains the result. And the thing they do then is a cat maybes to transform all of the maybe values in it into... to only keep the values that are not nothing. That way, I can use a nothing in the cache to indicate, oh, we tried to process that thing, it failed, but it's still in the cache, therefore it won't be processed in the loop. So now, this becomes a tiny bit more complicated there, but that's fine. Becomes a tiny bit more complicated, but that's fine. So this will give me... This is going to give me the new symbols. And this is going to be a hash map created from a list obtained by doing this. And new requests will be obtained by looking into the state. And the result of this function will be pure of the new request and symbols. So process request will need to know about the cache. So here are the new requests that we return, and the result of having processed those symbols after checking that they're not in this cache will be a union of the new symbols and the cache. Okay. So this function here now also takes a cache as an argument. And instead of returning something like this, it must return it will return something which is going to be a map from name to symbol. Okay? So now, and the symbol will be a maybe value. And I suppose this unless no longer works. So what I need to do is instead a simple case of a lookup. Well, if the name is part of my cache already, then there's nothing to do. Haha, but I don't have a way for this function to return nothing. So I will probably... Because there's a distinction between returning, oh, we don't need to add a value for this. I could cheat and do the union like this, because in case of a key conflict, the first one will be kept, and therefore if I have nothing to return, I just return nothing. But that feels a tiny bit inelegant. So I think instead, this function will return a maybe of the tuple key value if we want to insert something. And if we do, so then at the end here, I'll have to first cat maybes that list that we have obtained from processing the request for each request, which gives us, from a list of maybe value within our monad, we get a list of values, and we can then make that a hash map that contains maybe values that will then here be concatenated into a cat maybe. Okay, so this is going to be a list cat maybes. And so in the case where we already have that symbol in the cache, we've been asked to try to instantiate a function we already had, we have nothing to do. We return nothing. Otherwise, we try to obtain the symbol in the cache from our dependencies, because again, maybe this is a generic function that has already been instantiated by another module we depend on, in which case we still need the symbol, but we can reuse it from another dependency. So we do that. And if that gives us nothing, that means there wasn't... but that's a bit more complicated. That's a bit more complicated. That gives me a maybe value. But I don't want to do just an on nothing. That's not gonna work. Because this is gonna be of a type which is... Yeah, on nothing will not work here. I'd like to avoid doing an explicit case switch here. How do I do that then? I guess this is my asum m thing again. Where I'm gonna try a bunch of things that return a maybe value and keep the first one that is not nothing. Yep, there we go. So here, and the default will be... And the default will be nothing. Empty happens to be nothing in this case. Yep, that works. So that means we're gonna try first to do this. Look up into the thing that gives me a maybe value. If it is nothing, we attempt the second case, which is this thing, which I'm gonna put in one line. And if this gives me a non-nothing value, we return that. If both of them fail, well, fail. If both of them return nothing, oh, and for this to return nothing, it needs to be wrapped in a try. If both of them return nothing, this symbol is nothing, which is fine, because what we return at the end is a map from the name to maybe the thing. With this done, it means we will try to process to instantiate as many functions as possible, regardless of whether they encounter an error or not. But we will still label a function as processed, even if it yielded errors, which means we will not try to instantiate the same function twice. The only thing is, since our cache is not based on the base name, no, I think it's good. We have no choice. The problem is like if you have a generic function that the only type for which it will compile is int, and you try to instantiate with character, and then you try to instantiate with boolean, and then you try to instantiate with array of ints or something like this, you will get errors for each instantiation because we are not able to detect at this stage that like, oh, okay, the errors are the same, because you will have like type error for each kind, basically. I think that's fine. Okay, so that's basically it for this logic. Now, what we have to do is actually write the code. Draw the rest of the owl, basically. So here I'm gonna go back to core, the pre-refactor code, and look at what I do for functions. Here, is there anything I need to do that I haven't done? Type parameters are part of the name resolving. That's already done in the previous phase. This is just cache lookup that we don't need to do. Putting that in the scope, that's already done. Function arguments, I don't need to take care of. That's already done because that was done as part of the... Okay. That's the function type. That makes more sense. Okay. And analyze function is then just go to analyze block. That makes sense. And analyze block, I don't think I need the nested context, which is convenient. So this is purely a traverse. The question is, will I want to do... I will want to do a try at some level to basically try to process... Ah, this is going to be interesting. I might need two kinds of recovery in my diagnostic monad, because there is probably going to be a point where I want to... No, okay, I think it's fine. I think I will want to, for a block, to try... I'm trying to decide, when do I short circuit? When do I try to recover from errors? And I suspect... I'm not sure, actually. Like, I think within a block, I have to short circuit. Like, if something goes wrong within a block of functions, I have to short circuit. However, I guess when I branch, if I do like an if then something, or I have a while loop, I could decide, okay, that while loop doesn't work, so that thing I can't output, but I should be able to continue processing other statements, however, afterwards. So there are some statements that I will want to... There are some statements that I will want to catch, and some others that I will want to continue processing. Because if there's... Actually, do I want to just continue for all statements? Do I want to silently to catch errors on all statements? I think I might want to do that, actually. In the sense of like, okay, your let statement there is wrong, and that just means that anything afterwards will be kind of broken. Yeah, no, I think I want to do that. So I'm gonna copy that as like a starting block, basically. And I'm gonna change, maybe not all that. All of these, a lot of it is gonna be different. I think up to here, that's reasonable to bring into the new code. We're gonna replace the word analyze by the word validate. We're gonna replace the word, oops, that's not what I meant to do. This is supposed to be, not timeline. What's the name of that buffer? Roadmap is what it's supposed to be. And I just needed to readjust that a tiny bit. Nope, there we go. And scroll that back up. Perfect. So, I need to also change my analysis stuff, which is going to be, because it's called analysis M, and that is simply incorrect. Now, this is now called validate T of M everywhere. There we go. And the rest we can change manually. So given some monad M and a bunch of with location statement resolved, I'm going to want to translate that into a bunch of statement validated. And what I think I want to do here, since I don't need to set the context anymore for this, wait, no, I don't need to set the context for this anymore, since I have done all the name resolving again, so I never have to worry about am I in a scope that's correct or not. I've already done the work at this point. So now this is purely a traverse of try nested of validate statement. I can even write it point free, I think. It's that. And then that's an ensure nested of that. That's basically what it is. So we try each statement and we ensure that the result is correct, therefore that all of them have succeeded. But I've tried all of them regardless. That's a validate block. We have nothing else to do here. Validating a statement for some monad M that we will expand on at a later point. That's a statement resolved, and I want a statement validated as the output. I do indeed set the current location at the location of the statement. This is going to be used for error handling. Like, oh, throw an error, fetch the current location, include that in the error. And now this check of whether we are in a loop is no longer going to be performed here. Before, I was keeping track of like, are we currently within a loop? If no, throw an error. I have to do that work again when we do the lowering into AR. So since when we do the lowering into AR, we do the control flow analysis, it means that it's going to be a bit late in the process. Some functions that will look like, compiled, sure, will fail at a later stage when we do the lowering into AR, but that's fine. It will still fail before their dependencies are processed. So at this stage, we don't do any check. There's nothing to do. This is pure a continue statement. We do the thing for break as well, since the control flow analysis will be later on. At this stage, now there's no need to do anything. So now I have this return statement. I'm gonna do the thing again of opening the AST here. So a return statement is just maybe an expression type, and an expression type, when we are, and the output of the resolve thing is the basic one. Okay, so we are gonna need here to return the validated to get the validated expression, which is gonna be exactly that, except for the name. I think it's, how did I name the top function here? Validate const exp. Okay, so this is gonna be, unless I decide to be more explicit, it's maybe, yeah, I think instead I'm gonna do this thing where if I have exp and a word boundary, let's do expression instead. Oops, that was already wrong. For variables, I don't care. For functions, however, I think I want to do that. Okay. Nope, that was wrong again. Nope, nope, nope. Nope. Yep. Nope, nope. Ah, that's fine. Validate cast expression. Yep. Nope. 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 Okay, with this, all of the functions exported by this module will have a slightly more explicit name, which I prefer. Although exp is pretty explicit already, there's not a lot of things that are abbreviated like this, but you know, might as well not abbreviate unnecessarily. And now that should be almost all of them. How many functions are in this file? Okay, with that done, we can go back to here, and this is going to be indeed validate function expression, which doesn't exist yet. We'll get to it in a second. Now, we are going to need to look at the return type, which is going to be obtained from the context, which we have, which is here. That's the type of that's the return type of the function. And we do indeed a maybe unit type, so that's no longer required. So that is, oh wait, I'm wrong. This is, interesting. In this old version of the code, the validated expression might not have a type. Interesting. Now it always has one. So what I want to check is, oh wait, no, of course. The maybe here is because this is a maybe value, because maybe there wasn't an expression. And what I need to check is, yeah, okay, maybe unit type is correct. And this is no longer called this. This is type info of the validated expression. A lot of things have changed, but the logic is the same. The function return type is indeed uses current fun type. That's correct. Except I don't need to do the from maybe unit type. That's already done for me. And unless those two match, then report error wrong type. Okay, perfect. Expression return type, just to be clear, and function return type. And unless they match, then return an error. Otherwise, we return a return statement with the validated expression. Perfect. So that logic remains very similar. Here, there's going to be very similar, except now it's the validated from the resolved instead of being the resolved from the past. So this is that, but with the resolved one as an argument. Aha, I don't think we need... Ah, no, actually, we might still need that. I think we might need... I'm gonna leave this here the way it is, with the to-do and all, because I don't think we have a better way to do this at the moment. And that's just the type info of the validated expression. But what this says is basically, if the type of the expression at the top level is not unit, then if it's not something that it's okay to ignore, we should emit a warning. Actually, I don't know why I'm doing this. The assignments are all unit. So the only reason we will ever want to accept something at the top level that returns a value that's being ignored, that's a function call, basically. Rust has a thing where you can select a must use, where if you have a function call and its return value is not used, that emits a warning. Here, by default, I'm assuming that, like, no, okay, calling a function, if you don't use the result, that's fine. But we could imagine, hello, we could imagine having like an option in the compiler that adds a warning. In this case, we're like, a top level function, return value not used. But basically, okay, we have a expression at the top level in a thing that does something that's not unit. That should emit a warning. For instance, if you have like a 3 plus 3 in the middle, as an expression in the middle of a function, that should be at the very least a warning. So that should be probably a warn. There we go. I still haven't decided how I'm gonna name those functions. When I get around to actually implementing the diagnostic monad, then we'll figure that out. And here again, there's a lot less work to do because first we're delegating a lot of future work to validate function expression, which we haven't implemented yet, but also because since we have split the analysis phase in two, half the work is already done by this point. So here we have a let expression. So what do we need to do? We need to validate function expression that remains the same thing, except this is now validated instead of resolved. We need to validate the type, if it's provided, of course. Yeah, let's do that. So we look at the type. If there was a type indeed, then the validated type becomes validate type. Allow placeholder is not a thing there. Oh, I guess partial type is allowed. So this is validated partial type. Because what that means is basically it's fine to do something like this. Let x of type vec of underscore equals foo, basically. And you don't have to give the type of this thing. It can be inferred. But if you give the type here, I will make sure that this matches this. But the underscore means it's fine. It can just be partial. However, that means that in this case, I have a type, and I will need to check that. I will need to check that it matches the shape of the type info of my validated expression. However, type matches is not the right function for this. So let's go back, I think, to type, actually. Validate type pattern is what I want. I have a partial type and a type, and I want to just throw an error if it is incompatible. So validate type pattern is what I want to do. Here, this is just validate type pattern of the type first, partial type first, then type. Okay. The partial type is therefore this validated partial type. And my type I compare against is this one. This goes away. And this returns the resolved type. Okay. Except, this might be a thing where I want to do something different. Do I have validated? Is my AST different at this stage for a let thing? Because I might not, I don't need. Yeah, I don't actually need the validated type. If it's there, it's just to ensure that it's just for checking, so I don't actually need that. I can just reserve this thing to like, oh, I need to check whatever is in there, but I don't need to actually process that information. The type, if there's a type present, I have validated that it is correct. So the type of the expression will be enough. This was checking that the name of the variable wasn't reserved. That's done in the previous phase. The role is already done in the resolving phase. Name shadowing warnings is already done. Scope is no longer something that is required in this phase. And so the only thing that's left, I think even in this case, the identifier is no longer required. I can leave it. It's fine to have it. But it's really not required. And this, I can just replace that by being a typed expression. And therefore, that is just my validated expression. Okay? So we've handled continue, break, return, expression, let. Now, if is going to be a validate if that we delegate to a separate function. I am kind of tempted, even though it's going to be very short for most of them, to do the same thing I've done for expressions, which is to introduce more functions so that the code is more verbose, but more decomposed into smaller things, which means this would be replaced by validate return statement of the return expression, which becomes its own function there. That's going to take the return expression. Yep, and that's going to be that. And this is going to be a function that, given some modad m in which we operate, given some maybe expression, so some resolved expression, I will want to have an alias for this. So maybe resolved expression gives me, in my validation monad, a statement resolved, a validated statement. I will need a bunch of aliases that I don't have yet, but I will do that in due time. Yeah, I think then this remains the same. Well, except, no, that's correct. I returned the statement, so this takes the maybe thing here. Okay? Perfect. So here we're gonna do the same thing. Validate expression statement with the resolved expression, or just expression in this case, I suppose. Up. Gonna copy this because it's gonna be very similar. This is validate an expression statement. And here I have the resolved expression as an argument. But this is not a maybe, that is directly a thing. And this is it. Okay? Which means instead of having a very large case switch with like some bunch of code in line, the case switch just delegates to a function each, and each has a very clear name. Which means if at any point one of them needs to grow, that's already like it's fine. So this will be, I'm gonna do something similar. Actually, I'm even gonna copy this. Up. Let info. This is gonna be validate let statement with the let info. Put this here. This will take a let info resolved. Actually, since I'm gonna do a resolved let info like this, and will the compiler be smart enough to realize that this let info constructor maps this type, or will I have to be explicit and say, well, this is the let info constructor that comes from common? I might have to do that. But regardless, this remains the same otherwise. We are getting a let info, we are returning a statement. And we are doing this that we had already done. Perfect. And so now our validate statement just branches based on the kind of statement we have found. Interesting. For the if statement, I am not returning a statement. I am returning an if info. Oh, and the reason for this is, of course, that an if info, where are you, if info, may contain an else info that it then itself contains an if info. So I think I want this validate if is not validating the statement, I suppose. Or I suppose I could make it as validate if statement that gives me the statement and use another function for the recursion inside. So let's do that. And let's go fix validate if statement. This is taking as an argument in some m, the context of which hasn't been refined. We are taking some if info that has been resolved, and we are returning at the end a validated statement. And we are gonna go with the function. This function is its body is gonna be in one word. It's just gonna be go basically, which is gonna be the name of a recursive function that solves the thing, and after which we will just do an fmap if statement. There we go. And go will be the thing that's given some if info. will do that and return the if info. So validate function expression. Yep, that's correct. Validated expression. Oh, I do. Do I have many of those type matches here? Because I have introduced. Yeah, here I'm using this type matches thing. I have introduced some helpers for this in, I think, either types. No, I think in expect. Expect type, expected actual. There we go. So I can replace this being expect type of ref and return type and the expression return type. Saves me some code here. Oh, wait, why do I have... Oh, that's the end of my function. That makes sense. Okay. Do I have any other such... Well, this is not an expect type, I suppose. So this one is fine. I need to actually check it matches unit type. So that's different. There we go. Here I have another one. And here I can say expect type Boolean type of the type info of my validated expression. There we go. So if the condition of an if isn't a Boolean, that's an error. Validate no longer exists. Resolved body, well, I'm gonna just do a, I was gonna do a copy paste, a full replace, but I can't do that yet. Validated here, validate block likewise, no action, so this is just getting the if body. Traverse validate else of the if else, and we return validated expression, validated body, validated else. The only thing is, do I want to attempt I probably but I can't do that unless validated else becomes a part of this thing here. That here calls go recursively here, which I think I want to do. Okay. Okay. Now, do I want to do some error recovery here? Like, for instance, I think it makes sense if something is wrong in the body of the if to still try to process the body of the else. Likewise with trying to continue even if the type of the expression is not Boolean. That's a recoverable error. So I think what I want to do is validate condition is going to be something that given an expression is going to do this basically. So validate it, do the additional type check, and then return the validated expression. Which means here I can replace this by validate condition. And now those three things I can put in a try. Which means even if we get an error in this one, I'm gonna try to recover from it and continue doing things. However, those three things are now maybe values, which means I cannot use them, I cannot return something with it, so I will need to ensure over lift a3 of if info. So I'm lifting this constructor to be inside maybe. So this will try to construct something with those three maybe values. It will only succeed if all three of them are there. And ensure is a function that doesn't exist yet, but in our diagnostic monad will transform a maybe value into like, yeah, nope, either we have the value, we can continue, or we don't have the value, and we go back to short circuiting because of an error. So this is the recovery for the if statement, to try to continue even though, like to try to do as much as possible, even if a statement, even if one part is incorrect. Like if there's something completely wrong in the if block, but the else block is fine, we can still check that. Okay. Validate condition is done, and I think validate else is literally just that. If we have an if info, we just go recursively with this one, because we don't want the statement, we want the if info. Otherwise, we have a block, and we validate the block. Okay. So that's validate if done. Which means if we go back to this big case switch here, we are left with, I'm going to do the same thing. This is going to be moved into a new function, validate while statement. Actually, I'm going to do this and copy even that. So this is a while info, and we are going to do validate while statement of the while info. Put that here, copy that. Validating a while statement takes a while info resolved and returns a statement. And this function decomposes the argument and opens a do block and do this. I'm going to do the same thing. I'm going to introduce a where validate condition, I think. Oh, I could even make actually a validate condition could become a new function altogether because it's useful for a bunch of things. I guess it's only useful for if and while. Still, it doesn't hurt. So validating a condition is given a monad M in which we operate, given some resolved expression, give me a validate T M of a validated expression. And this is just validate the expression, then check that its type is Boolean, and finally return it. I don't need pure with this. Okay. So now validate condition is, the use here is the one below. And now I can do the same thing here. Validated expression is try a validate condition of the while expression. All of this is gone. Validated body is validate block of the while body, which is also in a try. And this becomes an ensure of a lift a... Oh, actually, it's too good. No, it's fine. This becomes a lift A3 of while state... Oh, well, Okay. This becomes an fmap while statement of lift A3 while info, or lift A2, I suppose, of the validated expression and the validated body. Again, since I'm using try for both of them, because even if the condition isn't a Boolean, I still want to try to gather errors in the while, in the block of the while. I do a try on each of them, so both of those are maybe values. So I lift the while info to try to construct something within maybe, which means this whole thing gives me a maybe while info, if we succeeded. And I try to make it into a while statement, and I then ensure that to make it... I guess I could even just do that. To make it into, like, bring it into our monad, which has diagnostic capabilities, or will have at some point. Okay, so that's while statement done, and it is a lot easier than it used to be. And with that, we are down to just one, which, since we don't have support for arrays and ranges at the moment, is not the most important yet, but still we can put things in place for later. Validate for statement with the for info. And I'm just gonna copy that here. And that's a 4, that's a 4, that's a 4, but otherwise everything is the same. So a bunch of things are going to be left to do because I don't have ranges support yet. However, validating that the name is not reserved, that's already done as part of the previous phase now. This thing of let variable is for scope resolving, which is done as part of the previous phase. Name shadowing is part of the previous phase. Loop context is no longer required, so validated body becomes validate block of the for body. That hasn't changed. Validated expression is for now just gonna be that. Yep, I think this is correct. We need to check that this is indeed something that can be iterated on. Like this needs to be a range expression, basically. So maybe at some point we'll have validate range expression here. But since we don't have that yet at this point, it's fine. This will always error. So I'm just gonna say unimplemented for now. Because we can't check any of that. And the result will be... So I'll probably want to do... I'm gonna put the things in place already, even if I don't need them yet. Oh, something is wrong with my... Yeah. And I probably have this mistake in a few other places. Yep, here, for instance. Okay, I don't seem to have it anywhere else. I will just want to introduce, so validate range expression is going to be the thing. Oh, I could actually even... No, okay, that's fine. This is where I'm going to do this kind of stuff. And then here, unimplemented. Because I don't have a notion of range or array or anything like this yet in the code. So this will just fail. But I can write the rest of this as if it worked. So the validated expression will be the result of doing a validate range expression and putting it in a try. Validated body will be the result of validating the block, putting it in a try. This will be an ensure of for statement of lift a to for info. 3, well, 2, and this is already given of the validated expression and the validated body. With the exception of, do I have something different for... Yeah, okay, for info, I have slightly different things. So I'll need the variable name, that hasn't changed. The variable type... yeah, okay, here is where I will need to have concrete type range expression. So I'm going to do something different. I'm going to do this try first, and I'm going to call it attempted, like I've done in a few other places. Not a great name, but I want to be consistent. Then I'll get the validated range expression and the range type, validated range type, as the result of calling validate range expression there, I suppose. Or I guess I could inline it at this point. Could probably inline it. So this goes away, this goes here. So here we are gonna have to do basically validated range expression, validated range type unimplemented, validated range expression unimplemented. Here I don't need to do any try. I've already done the body in a try. And here each step can't be performed if the previous failed. If the type is wrong, that's not a range, we don't need to try to process the expression into a range expression. Actually, this might be probably done in another function. So I might group them again into something like that. Validate range expression, I suppose, with the for range expression, which means I'm just moving the problem down the line, and then the validated body becomes just ensure of the attempted one. And with that, that becomes a lot easier. That's just pure of a for statement of for info with the variable name, the validated range type, the validated range expression, and the validated body, which I think, given that this line is getting a bit too long, I'm gonna indent like so it's more clear what's happening. This now expects the presence of a validate range expression which doesn't exist. So let's do that. This would be in right there. This would probably be somewhat high in this file, because it's going to be part of the few things that are going to be exported out of it. Validate const expression will be one of them. Validate range expression is going to be another one. And it's going to take something very similar. And validating a range expression. So this will be output no longer exists. This is a resolved expression. This is just a typed const expression. Well, except now this is a range expression for this function. And validate expression is just going to be, for now, unimplemented. We don't have range support at this stage. Okay? Going back here. So I think when I want to change every instance of this in this file to the new thing we have decided, which is resolved expression, where I'm going to use... I'm an idiot. Where I'm going to use... There we go. I'm going to use instead a type alias in the thing to say the type as it is defined as part of this thing here. There we go. Oh, that's the new one. Perfect. Perfect. And I suppose I can replace all... Yeah, output const expression is no longer something that makes sense. So I think I can just remove it entirely. Okay. Now, we're almost done, I think. Well, almost. You know, we're so far from being done, but... We've made some good progress. If I go back to core... yes. This will be difficult, and this is not done yet. because we have to do now. This is one function. This is one function of 322 lines. That's the one we have to do next. Um, Honestly, sorry, I hadn't seen your question. There's nothing that beats experience. I've been programming for 2 decades at this point. I use they them, not he. But yeah, I've been programming for at this point 2 decades. So 2 decades of doing this basically on a daily basis. I'm not very good at this. I've just done it a lot. You could. I don't. I'm not right. It's not written anywhere actually. Maybe I should actually write it there. Oop. There we go. You absolutely couldn't know, so no worries. But yeah, I've done this for 2 decades. So even if I'm not very good at it, after 2 decades of doing it, there's a point where you start like getting used to it. Plus, I like Haskell that I've been using for a decade, and I've writing compilers or compiler adjacent things. This is probably my fourth or fifth compiler like project in my life. So again, not very good at this, just experienced. And yeah, there is absolutely so much to learn. My goal of this, like all of the streams are put on YouTube. The not the code of this project is not super approachable. In December, I stream the Advent of Code, which is a lot more approachable because it is like the problems are a lot easier. Which means when I do stream the Advent of Code, I try to keep the code I write very approachable for people who are beginners with Haskell. For this project, since it is a much more ambitious project, the code is not as much approachable, but the entirety of the project, with a bit of lag, I'm behind by a few weeks, is on YouTube. So you can always watch the entire thing to see how I approach all of the problems. Errors and all, because there's been some mistakes. I'm currently in the process. Well, yes, sometimes I do the advent of code in brainfuck, but that's not something I would recommend as a source of learning material. That's for fun. But yeah, I will probably do some of it in brainfuck this year as well. There's one year, I think it was 2022 or 2023, where no 2022, in which day 25 of the advent of code, which is supposed to be one of the most difficult, was doable in brainfuck. I had to re-implement int64 support in brainfuck to be able to do it, but it worked, and that was extremely satisfying. I think it was. Let me check. Wait. There we go. 2022 brainfuck. I do indeed have a solution for day 25 part 1 in brainfuck for this year. Anyway, so this gigantic monstrous function is what we have to do next. However, I think I am not going to copy it from the old version for 2 reasons. One is a lot of this can be deduplicated for what we do for constants, and I have already introduced a bunch of functions for that. And 2, a lot of the code there will have to go away, because again, now that we've split this phase in 2, a lot of the work being done here is no longer required. So I think I'm gonna ignore this old code and start working. I might zoom this out a tiny bit. Let me know if it's too small, just to be able to see what I'm doing for a moment, because I want to duplicate this entire thing into validate function expression. I can put this back. Oh, this was fitting on the maybe I was doing it with this level of zoom yesterday. Oh, it's because I've replaced everything with expression. That's why it's no longer fitting. on one line. That's fine. So this is going to be basically the same. I have a expression with its location. The difference is I am no longer... why do I still have output there? I thought I had fixed that. I will want instead not a const expression, but an expression, because we are in the context of a function where more things are allowed. However, a lot of this will be the same. Except, you know, this won't be a const path expression. This would be validated in an expression. So I think I can try to remove basically in this. I can remove all names const, and that should be fine. Sometimes it will be, no, it will actually be replaced by function. So I will need to do this instead. So replace const with function. Validate function expression. Validate function cast expression. Validate function expression. Okay. This is wrong. We're going to have to fix it. Those ones are one where function is wrong, but we're going to... Actually, I'm going to fix it now. And continue doing our replacement. That's no longer a thing. Validate function expression. Oops. Went a bit too far there. This one's also a const. Okay. So that's basically the same logic as the previous function, but we delegate to functions instead of constant functions. Well, we function and constant here, meaning for our program. So here, instead of validating a constant path expression, we're going to be validating a function path expression. Here, when we go recursively for the expression, we use this function, not a constant one. So even though there are some similarities, the structure is the same. We are going to be validating things with slightly different functions. And my goal is going to be to try to reuse as much as possible. So like try to make validate function cast expression as close as possible to the const cast expression to deduplicate the code as much as possible. I'm okay with duplicating this big case switch because it needs to happen anyway, but I'm going to try to make it so that basically everything is just a function called to something else. So here, this is no longer true. A call expression, the error here that we have for a constant is like, hey, we try to call a function in a constant. That makes no sense. Here, however, we are going to need to do a validate function call expression. What do we have? If I go back to common, and I make that slightly smaller, and I go back to expression at the bottom, call expression is the path info, which is the thing that's supposed to be pointing to a function, and the expression type. Here, since there is no need to disambiguate compared to a constant, I am just going to say this is the function path, this is the function arguments, and I'm just going to give them to validate function call expression that doesn't exist yet, but that we are going to be adding. So we're going to need a validate function call expression, which for now is going to be unimplemented, but that we know that we have to do that. Okay. So that's path, cast, field access, call, done, array, index, not implemented yet because I don't have support for ranges yet. Struct, validate struct function expression. Ooh, that one is going to be a doozy. Because that's the one for constant. It is pretty big. I will want to try to deduplicate as much as I can of the code of this into the function version. Okay. Then we have literals. Those are very convenient. They're just that. String literal, we don't have arrays yet, so we don't have strings. That's fine. This will be, therefore, validate reference expression. Which is only valid in a function, so I don't think I need to qualify this. Wait. Wait a second. Is that correct? What do we do for references in core pre-refactor? Because references here are a very, very weird thing. Since we don't have pointers or anything like this, references are just a purely semantic thing I am using to say, oh, actually, no, this thing needs to be given as a reference to this function rather than as copy. It's technically not required. I could just reject a value that's given as an argument to a function that takes a reference, but it's just to make it very explicit. What do I put as the type? One thing that bothers me is I don't think I have at any point something that rejects references in other contexts, which means I could do at any point reference of x plus 3 and that would work just fine. So maybe that means that in fact I should keep this as an error because the only place where references are allowed should make this explicit. So this will be a error reference expression outside of function call or something like this. So I think here, yeah, I'm not gonna do anything special here. Yep, I think this is fine. Why did I give the expression for the Boolean negation and int negation? Yeah, since those are gonna be duplicated anyway. Expect. Yep. Yeah, I think those, I don't need to do this. I can just take a, oh, there is a big error in some of this work. No, okay, no, that makes sense. I'm gonna keep it that way. That was because the big error is expressions have location. But as a result, it is better to do it this way, where this big function here does stuff like calling validate const expression first to be able to set the thing. No, I don't think, no, I'm wrong. I can just do that. There's no reason to do that first. And those were the negation. There we go. So this becomes instead taking as an argument a with location of a resolved expression. And everything remains the same. And this is an expect const boolean of a validate const expression of the expression. Likewise here. Yeah. Okay. Like the line count has remained the same for those functions, and it's just like shorter in the grand scheme of things here. So I think I'm going to do the same thing for this thing here, where this is just going to take the expression. This is just going to take the expression as well. I think all of those validate binary expression with remains correct. I don't have anything for the range yet. And however, those are all valid now. Those are all valid now, because we can do assignments in functions, even if we cannot do that in constants. So I think all of those will be of the form validate binary expression with. Let's have a look at how I did that in core, actually. Okay, so I have a special case for the assignment, and then I have a helper for the compound assignment. Okay. What's the difference? Is that the same thing as this? What's the difference? Typed expression, analyze function expression. Unless is L value, unless type 1. Oh, I suppose. Yeah, okay, this is just that some types, for the compound assignment, I have some additional type checking to perform that I don't have to perform for an assignment. Because an assignment, as long as the type on the left-hand side and the type on the right-hand side match, that's fine. And but for a compound assignment, that is still true. But I also need to check that the value is of a type that I require for that matches. Yeah, okay. So I can deduplicate this. That's fine. I can deduplicate this. So let's make where do I put it? Somewhere down the line around here. This will be validate assignment expression. It will take, given some monad M, given some list of type that we, of concrete type that we want to allow. No, actually, this is going to be a maybe list of concrete type, the absence of which means we don't need to perform any type checking. And then this will take, what will it take? I guess it will take the expression on the left-hand side, the expression on the right-hand side, and if everything works, it will return a validate T of M of a typed validated expression. Okay. Validate assignment expression. Oh, it needs also the constructor. It needs to know how to construct the expression because each constructor will be different. It will be, it will be one of, it's not going to be in this file, it's going to be validated. Is it going to be the assignment expression constructor, the addition assignment expression constructor, and so on? So I need to also take as an argument do I put that first? Probably. It needs a function first, which is going to be a function from typed L value expression and typed expression into a typed expression. That's the constructor. So given the constructor, the allowed types, if any, the left-hand side and the right-hand side, what do we do? And this is where I'm gonna do that. So this is gonna be something where I will want to recursively do both. And try them so that I can try to detect errors down the expression even if one of them fails, and then I can do a validated of each. Which is just gonna be ensure of the attempted. There we go. So that will throw, those two lines will like throw an error and go back and short circuit if an error happened in either of those. But I will have tried both before throwing an error, which means even if there's something like if the thing on the left hand side cannot be assigned to its wrong as a left hand side, I will still have tried to also find errors in the right hand side. So in fact, this is not going to be analyze function expression. This is going to be analyze. Well, it's not going to be analyze at all. We are now in validate. But it's going to be, the one on the left-hand side is going to be a validate a L value expression. There we go. So now if I have this, this error, unless is L value, will be done as part of converting the expression into an L value. So it will be here. And now I will have, I can do an expect type of the type info of the validated left-hand side and type info of the validated right-hand side, which will check like, hey, does this type here match this actual type, match the expected type here? So if we have a variable and a thing, the expected type of the expression will be the type of the variable. So that's this check, kinda. And now the thing we need to check is if we have restrictions on this operator, is if this operator is only allowed on some types, like plus equal is only on numbers, which as far as we're concerned, since we have no floats, is basically only on ints, then we actually, maybe instead of doing a maybe concrete type, I will do that as a function that do I make this into a validation function that like returns a monadic action, or do I make that into? No, I think it's better to let every function decide how that should be handled. So this will be a type validation function, which will happen to be always like allow all types basically for when I don't need to do any type check. So I expect the types to match, and furthermore, I need to do some type validation. No, that's a bad name. Type validation callback. There we go. That's a better name. Of the type info. They are the same anyway. I can pick any of them. That's fine. And the result of this will be pure of the constructor of the validated left-hand side and the validated right-hand side. Okay, that's a lot cleaner than what it used to be. Perfect. We will need to have validate L value expression we don't have yet, but that's fine. So now I'm just gonna try to remember this. I'm gonna copy it so I have access to it. In this big nonsense, let me do that so that I have it here. For an assignment expression where I have E1, E2, this will be validate assignment expression. The constructor will be addition. It will be the validated assignment expression. The validation function for the type will be const pass. Basically do nothing. And the two expressions will be E1, E2. Now, I can replace in all of this, I can replace by E1, E2, and I can replace this nonsense with, for all of them, this is going to be validate assignment expression. The constructor will have to be changed, but it will be something like addition assignment expression. It will be the validated version of it. The argument to the callback for type validation will be expect type int type. Basically check that the type matches int type. Because for all of them, that's what it is. The only exception will be at some point addition that will also allow strings and arrays and other things for concatenation, but we are not there yet. And then E1, E2, the two sub-expressions. There we go. And the last thing to do is fix this. This is a subtraction assignment expression. This is a multiplication. This is the division. This is the modulo. And this is the exponentiation. There we go. Okay. So that's it for this big function. But with, of course, the big caveat that it assumes the existence of a bunch of other functions that do not exist yet. I think compare expect here and validate binary expression with is probably correct. Yeah, I think this is fine. Yeah, I think this is not required in the context of a function, I think. Because for constants, comparison needs to be resolved at compile time. But in functions, unless I happen to know the values, it's going to be very hard to resolve the thing at compile time. Although I suppose if I have two struct expressions... Oh no, I remember. This was extremely tricky. Because even if I have two struct expressions, so the shape of the structs I know at compile time, the fields might not be known at compile time. Maybe they contain functions, and I cannot really compute that at compile time. So doing comparison of structs at compile time in the context of functions, too complicated for now. So for comparison expressions, I'm not going to have that. So the only thing I'll need to specify is how to compare trivial value, like int, enums, and so on, where I can compare them at compile time. And that becomes a lot easier because I don't have to do all of this complicated logic. Comparing them is just doing this operator. So greater is this, lesser is this, greater or equal is this, and lesser or equal is this. Okay. Okay. Validate function call expression will be one of the worst. I am not going to do that. So I'm going to need a validate function path expression. Now is the part where I duplicate all of those functions to work on their function equivalent. Now here, this is where it gets a bit more complicated. Let's have a look at what we used to do in core. Resolve exp value was the name of the old function. It was not part of this, so it must have been part of the context. Yep, it was indeed. What were we doing here? We were looking at the role of the thing and deciding whether it made sense. Is it a function argument? Yep. Okay. So a lot of this has changed, so I'm not gonna copy paste this. Instead, I am going to copy in resolved this. So here, I'm gonna have to handle all of those. There's a lot that are gonna be easy to do, however, because I am in a context where in a function, I have found a path. For instance, let's say in the let of y, I have x plus 3. This x is a path expression. It points to something. As part of the name resolving thing, I have found what the role of that x is. Is it a built-in type? Is it a built-in function? Is it a function argument? Is it a function? Is it a other let variable? Is it the name of a struct? Is it a type alias? What is it? Well, since we are in the context of an expression, a bunch of those are not valid. So built-in type, not valid. Built-in function, valid because of function pointers. Struct, not valid. Enum, not valid. Constant, valid. It's perfectly fine to make references to constants. For instance, result is pi times something, and pi is a constant. That's perfectly valid. Function, just like built-in function, this is fine because we allow function pointers in this language. Type alias, not allowed. Type parameter, not allowed. Placeholder, absolutely not allowed. Function pointer is a... I don't think this is a thing I need to keep at this point. I think this is from the old code pre-refactor. I don't think function pointer is a thing that's going to remain. In fact, I'm going to immediately comment it out because I think this is dead code. However, I do have function argument, which is going to be arg name arg type. Why would I have a maybe type there? Why, when I'm resolving the type of a variable, do I... Oh, of course, if the let variable was not... Oh, that's annoying, though. Oh, well, fuck. Well, fuck. That's a bit of a problem. So, the thing is here, when I do a let, giving a type is optional because the type can be inferred from the type of the expression. However, what that means is when I do the name resolving, we're like, oh, at some point, like, what is this x here? Oh, it's this variable. What was the type of this variable? I may not have it because it was maybe not typed. And since at this point I haven't done any validation, I am unable to infer what the type of the expression will be. So that means I might just not have a type at this stage. How do I then check the type of this? Oh no. That means I'm going to have to keep something in my context. I am going to have to keep track of the type of the things I encounter. So I think even for the argument, for the function argument, now I guess I can just, nah, okay, for the function argument, it's easier to just keep it that way because the type will always be known. However, for a variable, it will just be var name. And here I'm going to need to have to change a bunch of things. Okay. So what does that mean? Let me think for a second. That means we need to go back here, and in context, I'm going to need to context variables. The scope doesn't matter because the scope has already been resolved, which is therefore simply going to be a hash map from base name to concrete type. This variable has this type. With context will be initialized with context variables being an empty, empty hash map. And I will need a new lens, which is going to be current variables, which will give me a hash map from base name to concrete type, or rather a lens to it. And it's going to be current context variables. Okay. Now I need to go back to instantiation. And here, every time a variable is declared, I need to put it in the context so that type checking can occur. So that means what is it called? This is validate let statement. Validate let statement. I didn't see this earlier. So I think validate let statement is the first of them. Like, okay, I have... Oh, actually, do I want to do... Don't do the thing here where I try to... Where I try to, like, do both just to ensure that, like, if something goes wrong, I have gathered as many errors as possible. I think I want to do that. So let's stack something else on top and let's fix this. And this is the wrong syntax here. This is supposed to be an equal. So validate let var type is going to be this stuff. I don't even need the do block here. This is purely that. Which means here I can first do a attempted expression. By doing a try of this, then I don't need actually to do that. I can just do that here. And then if this succeeded, I want the validated expression. So I do an ensure of the attempted one. There we go. So I have connected more errors. Because if there was an error in the expression and there was an error in the type, I have now both. At this point, I will need to current variables needs to be modified to do an insert of this name. Oh, that's not a base name. That's just an identifier. That's just a variable. This variable has this type. Up, there we go. Where else do I have? Where else is a variable introduced? The for statement is another one. So here, likewise, I'll need to do in the variables moving forward, there is one called for variable name that has the type info. No, it's gonna be the validated range type. Okay. And it's fine for the things to like not read, like I'm introducing this for variable when I start doing the for statement. It's fine for it to stay in the context because I've already done name resolving, so I know for a fact that all variables are pointing correctly, which means I will always... No, that's not true. Ah, that's not true. Oh no. That's not true because of shadowing. That's not true because of shadowing. If I have a variable x at the top level that has a value associated with it, and then within an if I have a for loop that introduces a variable with the same name, then I need to restore the scope correctly at the end of this, which means anytime I do a block, I have to restore the scope of the variables at the end of it. That's not the end of the world. But that means, however, that I'm going to have to go back to something I had before, which is here, the block first takes a function, which is a... What do we do to the scope before we start? And therefore, this will be a... init context, I suppose, and this will be the statements. What we're going to do is we are going to keep a copy of the variables from the context. Oh, use current variables. Then I'm going to init the context, which is going to change the context to make some new stuff in it if needed, which I think is only needed for the for loop, while loop doesn't need it. And then I will get my statements, my validated statements, well, my attempted statements, because I'm gonna use try on all of them, which is this traverse of try nested the validated statements of every statement. Then after that's done, I set the variables back to what they were. So current variables are set back to what they were before the loop, and then I return ensure of the attempted statements. There we go. So that means now that every call to validate block here needs to decide in the context of a if we don't have to do anything, in the context of an else we don't have to do anything, in the context of a while we don't have to do anything, we don't have to introduce new variables or anything like this. The only one for which we need to do something is this one. So I'm gonna do this first, and in fact I don't need to do the try anymore, because if I have failed to figure out the type of the range, so the range is not valid, then I don't have a variable for the loop, which means doing type checking in the loop is not gonna work. I mean, it might for some of it, but it's not worth attempting. So I don't need to do any try shenanigans anymore. I can just do validated body is validate block, and the thing we do here is set for variable, where set for variable is that. It's this monadic action where we put something in the state pointed at by this lens. Well, we modify the thing pointed at in this lens by this lens in the state by doing an insert of the variable name and the validated range type. And now we can do validate block. The init context will be set the for variable, and at the end of this, the variables will be restored to what they were before. Okay, fixed. Fixed. So now, whenever I encounter something that points to a let variable, it's something that has been introduced by a let, it's something that has been introduced by a for, and there's nothing else. And in both of those cases, I have set their type in the scope, in the state, which means I can guarantee that it's there. If it's not there, that's an internal compiler error. Okay. So let's see. What do we do here? Which one of those do I want to start with? Constant might be the easier. So this is gonna be validate function const value, I suppose. Just gonna be this. This is a base name. Let's be explicit with the thing. So first, I'm gonna check: have I specified type parameters for this path? Like, am I trying to say x of int? If it's a constant, that should not be allowed. Oh, actually, don't I have... I have a helper for this now. I have a helper for this now, which I think is in expect. No. Is it in retrieve? In context, I mean. Oh, the other context. This one. No, it's not there. Huh. I know I have something like this. Where did I put it? Since I'm not in the state where git grep is gonna be useful, let's go. Actually, I might be at this point. Verify constant value. Yeah, I have a bunch of when actual different from 0. I thought I had made a function for this that would deal with that for me. Haven't? Oh, validate params count with. There we go. I knew it existed. There we go. So all instances of actual. Okay, in this function, that should be fine. That should be all fixed. Where else did I have? I have some stuff in expect. Okay, so let's fix that first. This is in types. Validate params count. That's the one I want. Okay. So let's go to expect. Actual. Oh, no, those are fine. Okay. So let's go back to expression then. And let's look at all the places. Yep, there we go. This is a classic case of I want to do validate parameter count. The list of validated parameters is this one. And path params is the thing I want to validate. And this will do the thing for me. There we go. Okay, that was all. Still, let's progress. So, next. I have validated that it points to, that it doesn't have any given type argument, which is important. And now, oh, actually, is it actually redundant to do here? Is it done in retrieve constant? I wonder, actually. It's not. Okay. So this will attempt to retrieve the definition based on the base name. And then this will assert constant. Aha. But this one is something for a const. Ah, that is annoying. Do I have a way of making this polymorphic so that it's able to give me an expression if it's not a constant? Let's have a look at assert constant. I think this is... Oh, wait, no. Constant will always give me a const expression. By definition. So I think in this case, the fact that it gives me a const expression is actually perfectly fine. So retrieve constant gives me a const expression. Perfect. However, now I have to convert this const expression back into an expression. That is going to be... That's probably a helper function I want to make separately, because that is going to need to happen more than once, I think. So this is going to be a fairly trivial to expression. Or maybe from const expression. And let's introduce that in a helper here. From const expression is something that's going to take a const expression and return a validated expression. And this is always total. There's no errors there because const expression is a strict subset of validated expression. If I had made const expression, if I'm more and more tempted to do that actually. Let me explain what I mean. I am more and more tempted to, instead of having expression and having const expression and so on, which are like distinct types, I could do something where, but it's going to be horribly verbose. So I'm only going to do it if really the gains are very important. I could do a thing where here I have a extension type for each thing, basically. Like something like a x something, like for this one, well, no, not for the literals. Literals are fine, always. But for something like a local variable expression, is that something that's allowed in an expression or not? This could be like x local variable expression, basically, given some type parameter there. And I could say, well, if this is a function expression, then this maps to unit. This constructor is valid. If this is a const expression, this maps to void. This constructor is not valid. And suddenly, it's the same expression type from one to the other, with the only difference being what is the type argument here. And that makes a lot of functions, rather than being either it's an expression or a const expression, those types have nothing to do. It takes an expression with some type parameter, and you can still reason about which constructors are possible because some of them will just be possible in some contexts. So that's a possibility. The downside being I have to introduce a extension type per constructor, which would be horribly verbose. So I don't think I want to do that. I think I'm okay with having a bit of duplication, but the price is simplicity. The price is duplication. The benefit is simplicity. This big approach with the extension types would be a lot more complex, but it would reduce. It would be a lot less verbose in some places. Okay, so here from const expression is going to be a simple case of trying to construct a valid expression from those things. The leaves are going to be trivial. Okay. An array const expression. Why do I have... Yeah, I suppose I have them because at some point I will want to have arrays. That's going to be a very simple an array expression of map from const expression of x. And for a struct expression, this will be a struct const struct expression, not const expression, where this is going to be a nested f map. So within an empty, within the tuple, within typed. So it's an f map 3 from const expression of x. There we go. That's fairly trivial. We can go back to our path expression thing. What time is it? Not too late yet. Okay. This one is going to be, I'm going to move down the line. It's going to be a bit further down. Probably here is fine. Okay. So here for a constant, from const expression of retrieve constant, perfect, we're good. Then a function argument, and a let variable. Those are probably the easiest to do next. Validate. Validate var path, and that's the variable name. Here is where we're going to need to introduce a small helper for retrieving the variable type from the context. Retrieve variable type from its var name. So context. Retrieve definition, retrieve something. Okay. Retrieving a variable type is something that, given a base name, will give us a concrete type. Yep, that's gonna be it. And this is gonna be a simple uses vs variables, the lens into the cache of variable types in our state. The function we do on it is a lookup of base name, and an on nothing. Oh, maybe I should. I should be more specific. Here I have a thing where the retrieve functions will panic if the thing is wrong. But those retrieve struct params, retrieve definition will not. Maybe I should be more consistent with my naming and therefore call that lookup. And I guess the lookup ones actually give me a maybe. Yeah, okay, no, so this is a retrieve. Because here on nothing, that is an internal compiler error. Because I know, because I've already done the name resolving phase, that we know what every variable points to, but yet I've tried to get the type of variable, and I'm like, nah, that one isn't in the scope. The problem is with me, not the user. This first argument I'm going to remove at some point, but that's fine. Variable type not found in scope. And the detail I'm going to want to include is, at the very least, the variable name. On one hand, this is kind of dead code, technically, because, like, if I haven't made a mistake, this code will never fire. On the other, it's still good to try to... this is not a base name. This is an identifier. Still good to try to be a bit more explicit about error messages. Okay, so now I have retrieved variable type. I can go back here. So here I retrieve the variable type. Is that all I need? I think it might be all I need. Because the expression I want to emit is just... This is going to be a typed with the var type, a local variable expression of the var name. Nothing else to do here. Validate arg path. What do we do in the context of a type of a function argument? Here we do have var name, base name, arg name arg type. Here we do have both the arg name and the arg type, because it will always be known, because it is always concrete. So in, oh no, in fact, that's a tiny bit annoying. That's a tiny bit annoying. So the problem is that this thing here is not a validated type. It is the resolved type when all the name resolving has been done, but it hasn't been validated yet. In fact, I mean, it has, the function type is known, but I haven't done the job of actually. I haven't done the job of actually. When I create this as part of the resolving phase, the type hasn't been validated yet. So I could try to use my variable thing cache that I've just created, but function argument types are slightly different because they can be references. And references cannot be assigned to anything like this. Oh, no, they can be assigned to. I'm wrong. But they need to be treated slightly differently. So here, I could try to create a new cache. It might be the easiest to just, well, in this case, I just have to validate the type again, basically. Do I have, if I go to types, do I have a validate function type? Function argument type? I don't. Interesting. That's fine. What do I do then for invalidation at the top level? Yeah, I have this basically. Which I cannot reuse in this case, because in this case, this is no longer a parameterized type. I'm in the context where I know exactly what the type. Yeah, yeah, anyway. Okay, that's fine. I need to redo the thing anyway, since the types are no longer parameterized, because I know if I'm trying to instantiate it that I am in the case of a concrete function. So I'm just going to duplicate this. There's no point in trying to reuse it. So this is going to be except I will want to create something different. So I think the whole function is going to be depending on that. So let's actually do that and do something here. Oh, there's something wrong somewhere in my syntax. That's fine. And by value, we will do something like that. Open a do block here. There is something wrong with my syntax because, oh no, this one is fine. Oh, of course, because case is not finished. Yeah, of course. So this is going to be a case of, this should be an archetype, which means if I look at resolved, this is a function argument that is indeed a function archetype. Perfect. So I can in fact rewrite this as case. That's the argument. And if it's by reference, if it's by value, I do two different things. Okay. So I will want to arg type will be the validate concrete type from the path. And the result of this will be pure of a typed with the arg type of a reference argument expression of the arg name. And in this case, where it's by value, I validate the type the same way, but then I'm gonna make this a local variable expression. Because in the context where the variable is not given by reference, it's kind of a local variable in the context of this. So I know it was pointing originally to a function argument, but it has become kind of a local variable. So that's fine. Okay, there we go. Next, we need to figure out functions. How do we validate functions? That's going to be basically resolving a function type. That's going to be tricky. I think built-in function for now I'm going to leave completely unimplemented because I don't have built-in functions yet because I don't know how to do them. So this is what I'm going to have for now. I'm going to have to find a way to create a function type. Because the type in the typed thing that will annotate this expression, this will be a function type. So I need a way to get a function type there. And the thing will be a function name expression. So I will need to get its full name because it will have to be concrete. Okay. Okay, that's gonna be difficult. But some of the work we're gonna do here will be the same work that we need to do for function calls anyway. The big difference being for function calls, we can do type inference. For this, we cannot. Because here, since there is no argument, and we don't have like a fully Haskell-like type inference system where we can actually, look at how the thing is used and decide what its type must be. No, we're purely looking at can I infer the thing from its own expression, basically. And if it's just a function name, it needs to be fully known. Okay. Now, I'll have the base name of the function, and I will have the type arguments that were given as part of it. Now, yeah, well, exactly. I just have to implement type inference. That's just easy, right? What I will need to know is how do I find it in the scope? And I think this will be just a case of looking at the definition cache. As in, this function must be in the definition cache and it must be a function. Okay. So we can do some of this already. We can do in context. I have retrieve type alias constant retrieve struct retrieve enum. I can add a fairly straightforward retrieve function that but the definition cache is based on the base name. No, that's fine. So retrieve function given the base name should give me, if everything goes well, a validated function info, because this is what we store for a definition of a function. Function type, this is a concrete function type. Okay, I'm just gonna keep it that. Wait, do I? yes, function type and function info are different things. This is going to be a function type. So this is going to be a concrete function type, basically. I could rename... Wait, why is it parameterized? Why is it parameterized? Why is it not concrete? Yeah, I suppose that I'm looking at the definition. So I'm looking at the definition of function foo. And yeah, indeed, the function foo might have a type parameter. Okay, that makes sense. So this is going to be retrieve definition, assert function, because since I'm looking at something that I had identified as a function, then the code, then my internal state must reflect that, and it's an error if it's not. It's an internal error if it's not. So I can go here and do assert function that, given a definition, will give me this type here. And if I have a function definition with a function type, the result of this function is the function type, as expected. Otherwise, I need to remove this argument. It's bad. Up. Definition, not a function. There we go. So now I can do assert function. So if I start doing validate function path with the base name, validate function path with just the base name, I can get the function type by doing retrieve function of the base name. And that gives me this thing here. So I have the list of type parameters, and I have the list of the arguments, and I have the return type of the function. Okay. Now, what do I need to do here? Since I have no way of performing... So here I'm going to need to validate that the arguments, that the number of arguments matches... Yeah, okay. So here my parameters, which are the path params, I will need to transform into types. So those will need to all be concrete type. So I'm going to traverse my path parameters to do a validate concrete type on all of them. So the type arguments given to this function, if any, must all be valid concrete type. I'm going to try that nested. And I'm going to get that as path params, validated params, as an ensure nested of this thing. Now, I will need to do validate param count, where the number of thing I want is the fun parameters, and the ones I have, I guess I could do... No, it's better to do it next. The validated parameters. So I should have one of them. I should have exactly the same number of arguments in my path than the one my thing expect. So if I'm pointing to a function foo that has like two type arguments t and u, I must be giving explicitly two arguments because I have no way to infer the type of the function purely from its context. Okay. Now, what else? I have in type, because now I have the parameterized type for all of the arguments and for the return, but I do have, there we go, reify type that, given some map from identifier to some kind of type, in this case concrete, and some parameterized type, solve the thing. So here I can get the function arguments, validated arguments are equal to reify types with the parameter mapping, and this is gonna be the a map of that over the fun arguments. But first, I'm going to need the parameter mapping, which is simply a hash map from list of zipping the name of the parameters with the types that were provided. Then I can validate the arguments. I can validate return type, which is simply going to be a reify type with the param mapping of the function return. And with that, I can create a validated function type, which is going to be a function type. Oh, I have made a mistake. Where are you, function type? This cannot be named function type because it will conflict with something else. So I'm going to have to name it the same way I name everything else, with info here. And this is a function type info. This is a function type info. This is a function type info, because otherwise I have a conflict of constructors here. So this is a function type info that I have gotten, which means I need to also change expect. This is a function type info, and I need to change context. This is a function type info. There we go. So here I am creating a function type with a function type info. Where the fun parameters are the same, they are unchanged, but the arguments are now the validated arguments, and the return type is now the validated return type. Actually, I'm gonna do it this way. Oh. And that means with that done, I am able to return that this expression, which is the name of a function that has been validated, is a typed thing where the type is a function type with the validated function info. And the type of the expression itself is a function name expression, because it's pointing to the name of something, and a function name expression. Oh, I'll need the name that I don't have yet. And expression and the function type info, which we have here, which is the validated function info. Okay, there we go. So the last thing that we need is we need the name. And the unique name of this symbol that is no longer generic is going to be the base name, and map assert name, I think it is. Yep, assert name of the validated arguments. Wait, no. Of the validated params, not arguments. There we go. Okay. And now we have a local variable, or an expression of type function. That's perfect. And since I don't know how to do base names, the built-in functions, for now, we're not going to do any of that. I don't know what I've... Oh yeah, I've changed something here. Which means, at this point, we're done with validate function path expression. Let's check that the cast stuff is already implemented. I had done some work towards that. That's the const version. That's the function version. That is very similar, but tries, if it can, to compute the value at compile time, but might not be able to. It just checks that the types are known. Yeah. Okay. Perfect. So yeah, we're done with cast for now. Let's go back here. We're done with path and with cast. Let's do field access expression. It seems to already be done, but I don't think it's correct. Yeah, I don't think it's correct. It is copy-pasted and therefore it's wrong. Oh yeah, and I'm doing the thing. Okay, I'm going to change that. I'm going to change that where I am validating the thing here first. There is not really a good reason to do that. I'm just going to do this and make it a one-liner. And same thing here. No need to do that. I can make it a one-liner. Okay. So this is in fact taking a resolved expression. And so is this. And so this takes the expression first, which needs to be validated first by doing a validate constant const expression of the expression. And this needs to be validated first by doing a validate function expression first of the expression. Okay. Now, here is where I'm trying to basically see if I can inline the value. If I then do constant inlining. And I suppose here that's not going to work as well. And I guess I can do that, actually. I can do that. Let's look at the expression I got on the left-hand side. Is it a known struct expression at compile time? If yes, I can just try to get the field and return the value itself directly. And therefore, I am just inlining. That's basically someone doing, here's a struct .x, basically. So I just can immediately extract the x. Can I do that? Is it correct to do that? Fuck, it might not be. It might not be. Okay, that's an optimization that I think is wrong. Let me explain. Here's what I'm trying to say. What I'm trying to say is, oh, in a function foo, I find something which is like someone does return of some struct s, where that has like a field x initialized by going make x, and a field y initialized by doing make y, and then returns that dot x, which returns some x type. And I'm like, oh, the shape of the structure is known at compile time, so I can optimize this. I can do constant inlining, and I can replace this function at this stage by return make x. Right? That makes sense. Because the field x of this struct will be the value that is result of calling make x. That is wrong. That is the lazy language user way of thinking, where like make y is never called since its value is never used. That's not true in an imperative language. And since I'm basing this on Rust, I would like to keep as close as possible to the Rust semantics. If this function panics, then this whole function must panic, and this optimization would remove the panics, the side effects, the everything. So no, this optimization is wrong in the context of a function. In a constant, yes, because I know that all the values are done at compile time, but this optimization is wrong in a function. So I can't do anything here. I can't do any kind of optimization. The only thing I can do is look at the type info of the expression and check that it is indeed a struct. Because if it's not, then I have a type error. So this should be a struct type of some kind. And I don't think I really care about... No, I do care about the type, because I need to check that the field name is correct. So that would be the struct type info. And here I'm going to have to do some stuff. Except this is not a struct express, this is a struct type. If it's any other type, then that happens to be wrong. And I can't really use... I can't use like expecting this type got this one, because I don't know exactly which type I'm expecting. I suppose the only thing I can do is wrong type here. I can report a error not a struct with the wrong type. I don't know what this error needs. Maybe this is wrong as an argument. We will figure it out. But yeah, in a case where I have a struct, I have the struct type info with me here, which is just, it should be a concrete type. So I have the base name and the arguments. I should be able to fetch the actual real type of the thing. So here I am going to need to fetch the struct, which is fine. Which is going to be the struct info. Yes, that's fine. Okay. Okay, so I will need to retrieve the struct info. I should have in context retrieve struct. There we go. So this will be getting the struct info in scope by doing a retrieve struct of the base name, I think. Yep. And that's the base name I have from the type info, which is struct base name. Okay. Here, I don't need to do any validation of the arguments. That's not required. The only thing I need to do is this. I need to look into the struct values that I have obtained to try to find the field in question. If I don't, then field not found. I guess report again. And with that, I now have the name of the field that I already had, but I more importantly have its type, which is a parameterized type. So now I just need to get the validated field type by doing reify type again, which means I'm going to need the parameter mapping again, which is going to be a simple zip of the struct params. Wait. No, since I know that the thing on the left-hand side is a struct expression, I know it has been checked. Therefore, I know the number of arguments is fine. I don't need to check it again. I just need to create. Okay, that is the parameters, and I happen to know in the struct type info what the arguments are. So I can zip that, did that, do a from list that gives me a hash map, and the field type will be reifying the type with the mapping of the field type. And now I can express this as being a field access expression. This is a field access expression. Do I want to put the struct type info there as well? Maybe I will want to do that. Maybe I will want to do that to avoid having, because I will have access to it through the type annotation on this thing. But the problem is the type annotation on this thing, if something is wrong in my code, could be not a struct. So I would have to do some check with internal compiler error to be like, oh no, actually this thing is fine. It just happens to I make sure that like I get the proper value. So maybe here I will want to. Do I want to add the struct type info here? To avoid the problem of the parameterized type. Yeah. That, or, and that might be a better thing, I change struct info. Yeah, I change struct info. Struct info is parameterized by f as well and contains a type tree of f struct info. So a definition is a struct info where I have the parameterized functor because the definition has type arguments. But there's a few places where this is in fact a known quantity. So this is a concrete functor. Which means it's going to break some stuff in the constant code. That's fine. Struct info concrete functor so that I don't have to redo type reification at a later stage. Okay. Wait, why do I have name here? Yeah. I don't need that. Okay. So this will be, at the end of all of this, a field access expression where we're going to recreate the struct, a new struct info, but with fixed stuff, which is going to be a struct info where we're going to give the struct params not changed, but the fields will have to be. So I'm not going to be reifying. I'm not reifying just the one parameter. I'm going to have to reify all of them. That's fine. This is on struct values. I'm therefore doing this on validated fields. This doesn't change. This is not a field type. And here I can therefore do validated fields. I guess reified more than validated, but doesn't make a big difference. And the type of the field is the field type, and the name of the field is just the identifier. It is just a field name. Okay. That should be fine. Okay. So now we're done with function, with field access. Okay, so now it's time to do a function call expression. Oh, wait. In this invalidate function path, I make a mistake here. And the mistake here is, whoops, I have instantiated a function. Therefore, if it is a generic function, like if it is a function that has type arguments, if its definition is generic, if it has type arguments, it must be registered for instantiation because it must be included in the symbols of this module. Okay. What will that look like? It will look something like this. Unless is generic, do. And put that in the queued instances, except it's no longer called queued instances. It's called instance requests. That is a definition of the function that is no longer something I have, so the is generic no longer applies. So here I'm going to have to do this a bit more manually. And that's going to be unless null the fun parameters. So unless this is not a generic function. No, sorry, unless this is a generic function, we have to do this. We have access to the base name. So I just create a request and file it for later. Here's the base name. Oh, do I have the definition? don't have the definition. So here I need to fetch the definition. Okay. But I think I have retrieve input definition. There we go. Do I have a way? Because I have retrieve function, but that's not the same thing. Oh, there's no error here. I suppose I could probably actually go back to expect. Ah, no, I have no way of expressing this. No, okay. So I just have to do this, where I need to retrieve a function definition. It's going to be slightly different. This is going to be a resolved function info, not to be confused with the validated function info. I suppose I'm going to call this retrieve function type. And therefore this becomes assert function type, and this becomes assert function definition. And in expect, assert is now assert function type, and assert function definition, which returns a resolved function info. It's not assert function definition. Okay. That should be fine. So now we can go back to exp. Retrieve function has changed. So this is now retrieve function type. And that's the only use of it. Perfect. Oh, but I was in the path. Actually, yeah, I was here. Perfect. And so in this case, I will need the definition, which I will obtain from retrieve function definition using the base name. That's all I need. And I can craft a request, which is a function instantiation request. Where here's the base name, the definition is the function definition. And the fun type is a validated function type info concrete, that is this validated function info. And the parameters are the validated parameters. And we only do this for functions that are not concrete, because if they are concrete, we expect the linker to be able to do that. We don't need to include all of the symbols within this thing. However, for instantiated functions, we have to, I think. Yeah. Okay. Now we have to move on. Except I might stop here for this evening because I'm very tired. We have to move on to a validate function call expression, which is gonna be, okay, I have encountered a function call, and I need to check everything, which means I'm gonna have to do the type inference of the function based on the arguments and so on, which means I might actually start next time, whenever that is, maybe tomorrow, but in all likelihood next week. I will start not with the function call. I will start with the struct stuff, which is all this complicated stuff, because the struct expression in a function will be very, very similar, and I will want to extract all of that logic for type inference, so that then all of that type inference logic is extracted, and when I do function calls, I can reuse it. And when we're done with that, we'll have done a lot of progress. Yeah, I think we might be one stream or two away from being done with porting all of the old code to the new approach, after which we just need to clean the we just need to actually define the diagnostic monad and error and fix error reporting. And after that, we can try to compile and see all the many thousands of ways it breaks. Because I haven't compiled in weeks. Because we broke everything. Just gonna quickly push that so it's not just on my machine in case something happens to my machine. I'm on a branch, so I'm just gonna push a bad commit with just no message at all. We will merge that back into dev when it actually compiles. Okay. I'm gonna stop here for the evening. Thank you for tuning in, and I'll see you all either tomorrow evening or next week.